In this section, we're going to continue working with exponents, but instead of integer exponents or negative exponents, we're going to deal with rational exponents. And rational exponents really just means fractional exponents. And so the rule with rational exponents or fractional exponents is if we have a to the m over n power, we can convert this to a radical expression. So the base ends up inside the radical, and then the denominator of the fraction is called the index, and it's the root that you're going to take it, okay, 2. So if it's like the denominator's 2, then it's the second root. And m is the power you're going to raise the whole thing to. So, for example, if I do a to the 2/3 power, that's the cube root of a squared. If I use numbers, let's think about it. Let's do, for example, 8 to the 2/3 power. Well, what that means is I'm going to take the third root of 8, and whatever that answer is, I'm going to square it. So again, because the denominator is 3, it's the third root, that's my index, and then the 2. So the cube root of 8 is 2, and then 2 squared is 4. Now, what's interesting is you don't have to take the cube root first and then raise the solution to the power. Notice that when I do that, I'm going smaller. I'm going from 8, and the cube root of 8 is smaller, it's 2, and then when I raise it to a power, I go bigger again. The other way that you could do this is I could actually do 8 squared first. So it would be the cube root of 8 squared is 64, and the cube root of 64 is 4. Notice my answer is the same. However, trust me when I tell you that whenever you can do the cube root first, do that first. Take the root first because that's going to make the number smaller, and then you can make it bigger with the power. So again here, x to the 1/2 power. Notice your index is 2. Now notice they didn't write the 2 because it's a default. The square root bar automatically is the second root. Anytime it's anything other than the second root, we write it. So when you don't see a number, you don't see this index here, when you don't see it, it's because it's the default and it's 2. So that question there is actually asking you x to the 1/2 power is what is the second root of x? X to the 1/3 power, what is the third root of x? And again, notice that this 1 here, it's like taking the whole thing to the 1/1 power, but since anything to the first power is itself, it's kind of unnecessary to write when something is to the first power. Notice in this last one, x to the 2/3 power, that means the cube root of x, and then the whole thing squared. So let's just do some examples and see how this works out, okay? So we've got, again, 4 to the 1/2 power, so I know that that's going to be the second root of 4, and that answer is going to be raised to the first power. So the square root of 4 is 2, and 2 to the first power is just 2. When I go to the next one, I know it's the cube root of 27, and whatever that cube root is, I'm going to take it to the second power. Notice again, this is the index. It becomes the denominator becomes the index or the root, and the numerator is what I take it to out there. So the cube root of 27 is 3, and 3 squared is 9. Now notice in number 3, we have a negative 1/4 power. So again, the rules of negative still apply. So I'm going to have to take it to the denominator spot. Now I have 1 over 81 to the 1/4 power. And now I'm able to solve this part of it. That's going to be the 4th root of 81 to the first power. And the 4th root of 81, I have to think what number times itself 4 times equals 81, and it's 3. So my answer is 1/3. And the last one here is going to be 16 to the 3/4 power. So again, that's the 4th root of 16 cubed. So the 4th root of 16 is 2, and 2 cubed is 8. And so we'll just get to kind of like more and more complex problems and different examples, but it's the same rule over and over again. Again, notice here I have a negative power, so I'm going to write that's going to be 1 over 1,000 to the positive 2/3 power. and then that's going to be the cube root of 1,000 squared. So I know what number times itself 3 times is 1,000. Well, it's 10. And 10 squared is 100. And so this answer is 1 over 100. Now, when I go to number 6, this one's a little bit tricky because notice you've got this negative here. Your exponent is positive, so that's okay. And so what happens is the negative is not being raised to the 1/2 power. So again, this is kind of like -1 times 100 to the 1/2 power. So -1 times the square root of 100, right? And so that's -1 times 10, or -10 is the answer. So, or you could think of it as just the opposite of 100 to the 1/2 power, the opposite of the square root of 100, which means the opposite of 10. And that's another way to get that same answer. Okay. When you come to number 7, though, you notice a little difference. Notice in 7, the negative is part of the group that's being raised to this fractional power. So -64 is actually the base, or what goes inside the radican. So then we need the third root of -64, and that whole solution's going to be squared. So the cube root of -64 is going to be, what number times itself 3 times is -64? That's going to be -4. And -4 squared is -4 times -4, or +16. And the last one is going to be, again, notice the entire negative is being raised to this fractional power. So -100 will go inside the bar. And we're looking for the square root of -100 raised to the first power. And here we have to ask ourselves, what number times itself twice equals -100? And you're going to see that no number times itself twice, or at least no real number, because we've got 10 times 10 is 100, and we have -10 times -10 is also equal to 100. So there is no number that works for this. So this is a no solution, or I like to say no real solution. We'll learn a little bit about this at a later date, but no real solution here. We keep going with some more examples. Here we've got the cube root of 27, and that solution raised to the 4th power. So we have 3 to the 4th, which is 81. Here we have 64. The index, or the root, is 2, and then we're going to cube it. So we take the square root of 64 is 8, and we cube that. And again, 8 times 8 is 64, and 64 times 8 will make it, I think it's 512. We keep going. Now we have here -32, and notice that it's raised to a -4/5 power. So again, I'm going to start by just putting the -32, the whole group, because the whole thing is raised to the power. I'm going to take the whole thing to the denominator spot. It's still going to be negative, but my exponent will no longer be negative. It'll be the +4/5 power. And then now I'm going to rewrite that denominator. I'm going to get the 5th root of -32, and that whole answer to the 4th power. So the 5th root of -32 is -2, and -2 to the 4th power is going to be +16. And there's your answer. And then we go to the last question, and again, notice it's a fraction, and the fraction is raised to a negative exponent, whether it's a fraction or whatever, but it's negative. So the first thing I'm going to do, like I showed you in that last slide, is what we're going to do is I'm going to flip the fraction. I like to flip it and do 100 over 121, and it'll be to the +3/2 power. And then I'm really ready to, I can either do it by numerator and denominator separate, or I can do the whole thing. So I can take the second root of 100 over 121 and then cube that whole solution. Since both 100 and 121 have a square root, I'm going to leave them as a fraction. So the square root of 100 is 10, the square root of 121 is 11. And now I'm going to cube that. So that's going to be 10 cubed, which is 1,000, and 11 cubed, which is 1331. And there's my solution. Now here we get to some where we're actually multiplying or dividing or again multiplying again. And so remember, we already did multiplication rules. You know that when you multiply, you add your exponents. So just because your exponents are fractions doesn't change the rule. The bases are 6, right? So if I had 6 to the second power times 6 to the third power, I know my answer would be 6 to the fifth power because I would add the 2 and the 3. Well, same thing here. It's going to be 6 to the 4/3 plus 2/3 power. And when I do the math, that becomes 6 over 6 to the 6/3 power, and 6 over 3 simplifies to 2. So it ends up being 6 squared, or 36. So you're going to add those fractions just like you would do if they were integers. Those rational exponents, as if they were integers. And then here again, it's division. Notice your base is the same, so you know that your answer is going to be 125. And what you're going to do is you're going to subtract your exponents. So 7/3 minus 5/3. And so that's going to equal 125 to the 2/3 power. Now I worry about, the radical and stuff like that. So I know that's going to be the cube root of 125, and that answer squared. So the cube root of 125 is 5, and 5 squared is 25. And the last one I notice, it's r to the negative 8/9 times r to the 17/9. So right now, I know that my answer, my bases are the same, so my answer is going to be r, and I'm going to add my exponents. So negative 8/9 plus 17/9 is going to equal 9/9, and r to the 9/9 is 1, and r to the 1 is just r. And so even though it looked a little bit more complicated, it's the same skills that you've done before. You're just working with fractions now. Now these look a little bit challenging, right? And so here you're going to have to, when you get to these kinds of problems, you're going to probably want to have a pattern that you follow or some type of methodology to what you're doing. There's different ways to do it. One of the things that I like to do is I like to get rid of these negative exponents first. So I'm going to have z to the 3/4 power times z squared, because I'm going to move that z up, and then z to the 5/4 power at the bottom. Now at the top, you know that you add your exponents. So instead of kind of thinking of z squared, I'm going to think of z to a power that has a denominator of 4, and I know that 8 over 4 is equal to z squared, because 8 over 4 is 2. So I'm going to now add 3/4 and 8/4, and I'm going to get 11/4. And then in my denominator spot, I have 5/4. And so because it's division, I'm ready to subtract. It's going to be z to the 11/4 minus 5/4, which is going to equal z to the 6/4, which I can simplify to z to the 3/2 power. And that's about as far down as I can get it. That's as simplified as I can go. And again, there were other ways to do it, but this is the way that I chose to do this one. When we get to 17, we have x to the 1/5 power times y to the 2/3 power all over x squared. And then notice that in the top, though, sorry, I forgot, this is being raised to the 15th power. So what I'm going to do is I'm going to distribute that. I'm going to make sure that I take the 1/5 to the 15th power and the y to the 2/3 to the 15th power. Remember that when you have a power to a power, you multiply. So it's going to be x, and I'm going to be doing 1/5 times 15. And when I do that, notice that when I do the math, I get 3. So that's x cubed. Then I'm going to go to the y. And I'm going to do y to the 2/3 raised to the 15th power. Basically means I'm going to do 2/3 times 15. So again, I get 10 there, so that becomes y to the 10. So even though it looked really complex here, when I took the power to the power and multiplied those, I ended up getting exponents that were integers. And then down here I have an x squared. So again, I've got 3 x's up top, 2 at the bottom. I know these two are going to cancel, and I'm going to be left with x to the first up top and y to the 10. And that's going to be my final answer on that one. And so that's how we do that. And then again here, same kind of problem. I've got p to the third power raised to the quarter power, and then p to the 5/4 raised to the second power. So again, I'm just going to multiply it first. So I'm going to do 3 times 1/4, which I know is 3/4. So this is p to the 3/4 power. The bottom one is going to be 5/4 times 2, which is 10/4. P to the 10/4 power. Now here, you might have thought, well, hey, let me simplify that to 5/2. But what I noticed was because this fraction is 3/4, I don't really want to simplify it because this way they have like denominators. And so with these type of problems, you know, think before you simplify because you might be wasting your time. So I've got p to the 3/4 over p to the 10/4. So it's going to be p to the 3/4 minus 10/4, which is going to be, let me erase some of this stuff. It's going to be p to the negative 7/4. And again, p to the negative 7/4 is 1 over p to the positive 7/4, right? So again, this threw in everything. This threw in remembering that a power to a power has to be multiplied. It took in the division where something that's divided, you have to subtract your exponents. And it also made you recall that if you have a negative exponent, you have to convert it to positive exponent for a simplified final answer. So there's a lot going on there, but the skill is basically pretty straightforward. The other thing is remember that you also, if you happen to have, you know, a radical, like I said, if you have like p to the 7/4 power, you can convert that to a radical, 4th root of p to the 7. And again, if you're given something in radical form, you know, let's say, let me use a different letter. Let's say you're given a totally different problem. You're given, you know, x, the square root of x cubed or something like that. You also know that that's x to the 3/2 power. You know how to take it from one to the other. Remember that, again, the root is going to be the denominator, and this number is going to be your numerator.